In this video, I'm going to talk about factors and GCF, or the greatest factors in GCF, or the greatest common factors. So, what is a factor? A factor is a number that divides another number, leaving no remainder. For example, if we have 4 right here, if we are going to divide it by 2, we will get 2 as the quotient. So when we multiply it by 2, we will get 4, right? So this right here, 2, is the factor of 4. Another thing, 4 divide 1, we have 4, and when we multiply it by 1, we will get 4. 4 and 1 is the factor of 4. Okay, so that is factor or factors. So now I want you to be introduced with the concept of prime factorization. Prime factorization. Okay, a prime factorization, when a prime factorization are whole numbers that are expressed as the product, or a whole number that is expressed as the product of factors that are all real, that are all what? Prime numbers. Let me rewrite it. It is a whole number, a whole number that is a whole number that is expressed whole number that is expressed, sorry, I have very bad penmanship, that is expressed as the product of factors, the product of factors that are all prime numbers. Okay, so the definition of prime factorization: whole number that is expressed as the product of factors that are all prime numbers. For example, if we have 14, 14 can be expressed as the product of 7 times 2. So this, the prime factorization of this is 7 times 2. Okay, so notice that 7 and 2 are all prime numbers, but actually there is a 1 right here, but 1 is not included because 1, we all know that 1 is always a factor of any number, because we can write 14 as 14 times 1. Okay, so what is a prime number? A prime number is a number greater than 1 that has a factor of 1 and itself. For example, 2. Is this a prime number? Yes, it is a prime number because we can express it as 2 times 1 only, meaning the factors are 1 and itself, which is 2. That is, this is a prime number. Prime number. So what is this one? 4. 4 is a composite number. Why composite number? When a number has another factors except 1 in itself, that means that number is a composite number, because 4 we can write it as 4 times 1, and 4 also we can write it as 2 times 2, meaning except 4 times 1 there is another factors which is 2 times 2, meaning this is not a prime, this is a composite number. 4 is a composite number. Now identify this, if it is composite or prime. Oh, okay, wait. 4, we have 6, and 5 we have 7. Okay, now 20. Just pause the video if you're going to answer this. Is 20 a composite or a prime? It is a composite. Composite. 10 is a composite. Composite number. 5 is a prime. 7 is prime. And 6 is composite. Okay. Now we're going to proceed to prime factorization or positive integer. Positive integer. What if we have this positive integer 25? 25 is a positive integer. We can express this number 25 as the product of 5 times 5. Okay, now look at this one. So the prime factorization of 25 is 5 times 5. Okay, now what if we have negative 20? What is the prime factorization of negative 20? Can I write this as the product of 10, or let's say negative 1 times 20. Then 20 can be expressed as the product of 10 times 2, and also 10 can be written as the product of 5 times 2. Notice here that 20 has the prime factorization of negative 1, 5, 2, and 2. So negative 20 has a prime factorization of negative 1 times 2 times 2 times 2 times 5. Okay, so negative 1 times 2, negative 2 times positive 2, negative 4 times negative 4 times positive 5 is negative 20. So what if we have this monomial, a combination of letters and numbers? What if we have 12 a squared b squared? 12 can be written as the product of 3 times 4, right? And 4 can be written as the product of 2 times 2. Therefore 12 has a prime factorization of 2 times 2 times 3. Okay, now in terms of variable or letters, this is called variables right here. The exponent should not be greater. Should not be what? Should not be greater than 2. It means it has only a 1 as the exponent. So it should not be greater than 2. So if we have this a squared, we can write it as the product of a times a. Notice that it has only an exponent of 1. How about b squared? We have b times b, right? A variable should have an exponent of 1. Okay, so answer this. What if we have s cubed, 6x cubed, 6s cubed, 2, we have 14, negative 14 y squared z cubed, then 3, negative 15 a cubed b c to the 4th. So pause the video and answer this. The answer for this one is we have 2 times 3 times s times s times s. This one right here, the prime factorization of this is negative 1 times 2 times 7 times y times y times y times, I'll just erase this, times z times z times z. Okay, how about this one? 15 can be written as 3 times 5 times a times a times a times a times b times c times c times c times c. Okay, I hope you get this. Okay, that's all.